Okay, fifth graders, we are working on, what is this, 14-4. And I think, I haven't looked ahead, I think this is the last section of chapter 14. It's a pretty short chapter on graphing. So in this one, they've given you some word problems. You're reading about them, and then you're graphing them yourself. So in this example here, it says in 1705, a ship sank in the ocean. At the point shown, and it looks like the point is, what is that point? It's 4.6, kind of small for me to read here. Every year, the ocean currents move the ship 1 mile east and 2 miles north. So it looks like east, and you can see that here, is the x-axis, and the y-axis would be north. So right away, I'm just, kind of projecting ahead to myself. It's 2 miles along the y-axis and 1 mile along the east axis every time I graph this. So then it says, where is the ship located after 4 years? Where is the ship located after 10 years? Tell how you decided. So what do you need to find to solve the problem? You need to find the ship's location after 4 years and 10 years. I wouldn't say that's what you need to do. Oh, that's what you need to do to solve the problem, I guess. Yeah, I'm not sure if I would. Yeah, that's kind of an odd question there. What do you need to do to solve the problem? That's telling you what the problem is, in my opinion. But anyways, I'm splitting hairs here. I'm not going to worry about that. How can I use reasoning to solve the problem? I can, and they give you some bulleted points here. You have learned about graphing points, you know what ordered pairs are, and you look for relationships in the coordinates and you decide if my answer makes sense. Relationships in the coordinates, I just want to talk about that for a moment here. The kind of graphing we've been doing, and you guys will be doing probably more of it in 6th grade, come 7th and 8th it's going to change. You're doing linear graphs, and linear is kind of a fancy word for a straight line. So the kind of graphs that you're going to be doing, the lines are straight, whatever it may be. And in junior high, 7th and 8th grade, you're going to start doing graphs that are not linear. They're not a straight line. But these ones are, and so you can expect to see them on a straight line. And if you label a graph, let me just give you an example here. Let's say I'm doing some points here. Whoops. And let me take that off. I do some points here, and you can see they're in a straight line. But then one of my points is like right here. Okay? Well, I think for now that would tell you, maybe I made a mistake in there, or maybe the information they gave me was wrong, or who knows. But generally, your graphs are going to be linear. And remember, linear means essentially a straight line. So that's a pretty good example. I mean, they graph the points, and then you can tell where the ship is after 10 years, and they give it to you there, 14.6. And then how could you decide if your answers make sense? I would say look for a pattern. And see if the lines are linear. So that would make sense, because it's going to be a pattern if the line is linear. So, okay, let's go to the guided practice. And I already copied the graphs and kind of moved them over. I'm just going to help you get started on these and let you guys do them on your own. Tanya marked a grid in her garden. She planted a rose at 3-1. All right, so I'm going to plant a rose at 3-1. So it looks like, so 3 is always the x value. Remember that. So I'm going to put x. Okay, that's a terrible x. I'm going to put x, comma, y, just so you guys remember. So 3-1, so I'm going to find 3 and then go up 1. So here's 2, here's 4, so 3 is going to be in between, then I'm going to go up 1 right there. And I could even write and you'll do this in some of your graphs, 3, 1, right there, just so we know what that is. And then she continued planting rose bushes so that each bush is 2 feet east and 1 north of the previous bush. So I'm going to go 2 feet east, 1, 2. So that brings me to 5. 1, 2. And then 1 more north. So the next rose bush would be right there. And I don't have much room to write. It's kind of small. Actually, I should have been using this one. It'd be a little bit easier. I think I will. It's a little bit larger. First off, I'm going to go to 3, 1 right there. And then I'll write 3, 1, 3, 1. And the next rose bush is at, what was it? 2 feet east and 1 north. So 1, 2, and then up north 1. So this one is, what is that location? That's going to be 5, 2. 5, 2. You don't have to label these like I'm doing, but sometimes you'll be doing a problem where it'll help just to reference back to the coordinates. Okay. How can a coordinate grid help you reason about the problem? Well, you can plot the points. You can plot the points. Draw and label the locations. Oh, okay, my bad. It does say to label it. So you guys do need to label the points just like I've been doing. Do they lie in a straight line? How do you know? Yeah, you guys can answer that question. What are the locations of the 5th and 9th rose bushes? I think that's a good class craft question right there. I'll want to know the locations of the 5th and 9th rose bushes. Okay. All right, let's move down to the next one. Independent practice. What have we got here? Our marching band uses the grid to determine the members' positions. Juan starts at 2-2 every 15 seconds. He moves 4 yards east and 3 north. Okay, so Juan starts at 2-2. That's going to be right here. And I'm going to label it because they may be, yep, it does say draw and label. Okay, so I'm going to put a little 2, 2 right there. Try that again. 2, 2. A little better, okay? And then it says every 15 seconds he moves 4 east and 3 yards north. Okay, the east is the x-axis, so 4 east. So from this point, he's going to go 4 east. So that's 2, 3, no, so 1, 2, 3, 4. Whoops, shouldn't have done that. So, so he'd be at 6 for the x-axis, and then how far north? 3. 1, 2, 3. There it is, right there. So let's label it. So he's at 6, what? 5. 6, 5. All right. So you label the rest of those, I would imagine. How can you model this problem? You can explain that or answer that question. Draw and label the points, form a pattern. You can answer those. I'm looking at number 5 now. How can you tell? What will Juan's location be after 60 seconds? Okay, so I think that's another good class craft question. What would his location be after 60 seconds? And then after 90 seconds? That's what I want to know. What will Juan's location be after 60 seconds and after 90 seconds? In other words, the coordinate pair. How does the coordinate grid help you reason about the locations? Well, again, you're just looking for a pattern, I would think. Okay, what else? Yeah, I think I'll just let you guys do this one. Toy company is testing the Rozo robot. Rozo is 18 inches tall and weighs 2 pounds. The employees of the company mark the grid on the floor and set Roseau at 2.5. All right, so let's find 2.5. Now, I just want to point out something here. I went ahead and copied it and moved this over. It's the same thing that this is here, and I labeled it, and you can see I labeled both east and north in yards. Well, that makes sense because that's what we're talking about. We're talking about yards. And I used increments of 5 yards. I mean, it wouldn't make sense to do increments of 20 yards each, or even 50 yards. I mean, I would hardly move anywhere on this graph, and even 1 yard would be too small. Then I'd be going off the chart right away. So sometimes you have to look at these and think about how far somebody is moving or something is moving on a particular graph, and that'll help you determine the increments, okay, that you use on the X and Y values. So 5 yards makes the most sense. So they set him at 2.5. Well, I'm going to go to 2.5. So 2 would be, well, I don't know, probably right about here. And 5 is right there. So, I mean, think about it. Look, if this right here is 0, 0, and you know it is, that's the origin. And if this right here is 5, right here would be 2.5. I'm going to draw a little arrow right there. That'd be 2.5 or 2.5. Well, where would 2 be? 2 would be just a little bit before that. And so from that point, I went straight up to the 5, because the first location is 2.5. And it says they programmed Rosa to walk 3 yards east and 4 yards north each minute. What will his location be after 7 minutes? Okay, so I'm going to highlight that because that's a great classcraft question. What will his location be after 7 minutes? All right, do you need all the information given in the problem to solve? No, there's some information up above you don't need. Label and graph. So again, we're labeling, so I'm going to label that point there. That is 2, I'll make it a little bit, make it in black here so we can see it here. 2, 5. And I'll even put the point in black so it comes up a little bit better. And then plot and label Roseau's position at the end of each of the 4 minutes. What tools would you use for drawing the line? I'm looking at the rest of these questions here. What will Roseau's be after 7 minutes? Yeah, you guys can answer these. Actually, they already asked that question up above, right here. I don't know why they're asking that twice. So anyways, yeah, that's it. And we will grade this on Monday if we have time. Monday is we start the state testing all next week. And so we won't have a regular schedule. I'll have to look and see what that is and let you guys know. But we will grade this Monday, just not sure when. Okay, that's it. I'll see you guys later.